I'm going to go ahead and review the extra credit questions just to clear up any confusions. So in the first one, most of you did pretty well with that. Find where the function has horizontal tangents. So what does that mean? Well, if we have this function here in pink and we're finding where there are horizontal tangents, we are setting the derivative, which is the slope of the tangent line, equals to 0. So if the tangent is horizontal, the slope of the tangent is equal to 0, which means the derivative must be set equal to 0. The next question was, what does it mean to be differentiable? Well, basically it just means it's able to be differentiated. There are some functions where we need to take a look at it further at specific point values. So the function must be defined at a specific point in order for it to be differentiable there. So for example, if we take a look at the absolute value function, it's not differentiable at 0, so absolute value of x is not differentiable, but it is differentiable maybe from negative infinity to 0 or certain pieces of the function. So basically I was just looking for the fact that it's able to be differentiated. Next question asked you, what does it mean when you're asked to find where the function has vertical tangents? Vertical tangents exist where f prime of x is undefined. So let's take a look at the function x to the 1/3. Here's a rough sketch of the function x to the 1/3. X to the 1/3 is continuous, therefore you can see that there are no holes or breaks or jumps, and the derivative of x is 1 over 3 x to the 2/3. F prime of x is undefined when x equals 0. So when x is 0, which is right here on f of x, then we have a vertical tangent. So therefore, f of x has a vertical tangent, VT, vertical tangent, not to be confused with asymptote, vertical tangent at x equals 0, y equals 0. Because f prime of x is undefined, f prime of x is undefined when x equals 0. The next question asked you, why would f of x equals 1 over x not be differentiable everywhere? Well, f of x equals 1 over x is not differentiable at x equals 0 because f of 0 does not exist. We have a vertical asymptote at x equals 0. Therefore, we cannot, therefore it's not differentiable at x equals 0 because f of 0 is undefined. Next question had you drawing a graph where the limit as x approaches 3 exists, but f of 3 is undefined. Some of you gave really great graphs, although some of you who gave this graph, you did not meet the conditions. Because although f of 3 is undefined, the limit as x approaches 3 does not exist because it's going off to positive infinity from the right and to negative infinity from the left. So a way to fix that would have been to either have them both going off to positive infinity or both going off to negative infinity. Some of you used holes, some of you did like an absolute value type thing with a hole, like that. Also great. So yeah, that was about that question. Next question, had you giving an example of a question asking to find the first derivative of x to the 3rd using the definition of the derivative. The limit as h approaches 0 of x plus h to the 3rd minus x to the 3rd all over h. This is asking you to do f prime of x for f of x equal to x to the 3rd. You can see your f of x right here. And here's your f of x plus h. That's f of x plus h. There is f of x plus h, f of x, all over h. It is a limit as h approaches 0. Again, f of x plus h, so x plus h to the 3rd, minus f of x, all over h. And that is the only answer I will be accepting. The next question asked you to give an example asking to find the first derivative of x to the 3rd at x equals 2 using the definition of the derivative. So f prime of x at x equals 2, with f of x being x to the third. And that one we will be doing the limit as x approaches c of f of x minus f of c all over x minus c. So the answer is the limit as x approaches 2 of f of 2, which is, nope, of f of x, sorry, f of x, which is x to the third, minus f of 2, which is 8, all over x minus 2. And that would be the question. So if I gave you this question, the limit as x approaches 2 of x to the third minus 8 all over x minus 2, you can find your function. There's f of x. And this is a limit as x approaches 2 of f of x. Here is f of 2. And down here is x minus 2. So this question in disguise is asking you to do f prime of 2 when f of x is x to the third. So that's what I will, this is the answer to the question. Give an example of a question asking to find the first derivative of x to the third at x equals 2. This is it right here. So the limit as x approaches c, f of x minus f of c all over x minus c. And that's that.